Hello all, this is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, come back when you think you have an answer. We're going over in 3, 2, 1, let's go. It says graph the solution of this system of inequalities. So let's do the first one, let's color code this. As soon as I see that, we gotta think, oh, there's an absolute value. That means something. That means it's going to be a V. It's not gonna be a line, we know it's gonna be a V. As soon as we see those absolute value symbols, remember that's a big part of being a good math student is seeing something and having an idea of what it's going to look like before we even graph it. Since it's an absolute value, we want vertex form, and it's already in vertex form because we see an invisible 1 in front of that x, so we don't need to divide out a GCF or move anything around like that. We can just go straight to our vertex using our h and k values. H will be a positive 3. Remember, whenever we're finding h, we change the sign of what it looks like it is. So it looks like a -3, it changes to a positive 3. But k stays the same. We do not change the sign of k. It looks like a positive 2, and it is a positive 2. So let's graph our vertex at 3, 2. Now that's a really important point because that's going to be the point of the V. So our A value, which we see is it's 1 over 1, since there's an invisible 1 in front of that absolute value. We have to graph that quote-unquote slope so that we get a V with that as the point. So going to the right, we pretty much do it exactly like we would a line. We go up 1 over 1, rise over run as many times as we can. Going in the opposite direction, we want to create a V. So we don't go down 1, left 1. That would create a line. We go up 1, left 1. Hopefully this seems familiar from our previous lessons. There we go. Now it's time to worry about the shading and all that. It's or equal to, so it's going to be a solid line. And it's y is greater than, since y is greater than, we think y is bigger, we shade above the V. We shade above. I'm just going to shade a little bit, and then we'll really shade it in once we have our final answer. The green, the second one, well, there's no absolute value, so that's going to be a line. We just use y equals mx plus b. The y-intercept, there we go. The b value, that's what I was looking for. The b value is positive 7, so we go right there to positive 7. And the slope is -1, so it's -1 over 1, so that's down 1, right 1, as many times as we can. A couple more, there we go. And then we don't want a V this time. This is going to be a line, so now we reverse the slope going to the left. Instead of going down 1 and right 1, we go up 1 and left 1. As many times as we can. It's or equal to, so that means it's going to be a solid line. And it's y is less than, so we're going to shade below. So then the part of this graph that is the solution set is when the shading is overlapping, so that's right in here. In this, it's not exactly a rectangle, but it looks sort of like a rectangle, I guess. And there we go, we're all done. So hopefully that's what you got. Let's move on to our objective. Today we're doing chapter 3, section 3, and after today we should be able to write systems of linear inequalities. Write systems of linear inequalities. This is going to be the last day we spend on this section, section 3 in chapter 3. And today we're essentially going in reverse order. So all this section, or most of this section, has been, okay, here's the system, graph it. Here's the system, graph it. What we're going to do today is they're going to give us a graph, and we have to come up with a system to match that graph. Let's take a look at example 1. In this example, before we jump into like a system, let's just deal with one linear inequality. Let's start, with the basics, and then we'll build up from there. So here we have one graphed linear inequality, and we have to write a linear inequality to match the graph. It's not a V, it's just a line, which means we can use y equals mx plus b. Now, obviously, we know it's not going to be equals, but I'm just keeping the equal sign there as a placeholder right now. Eventually, we will have to change that to less than, greater than, or something like that. Let me see. We see the y-intercept is 0, so it's going to be y and a plus 0. The slope, that looks like a good point, so that would be up 2 and right 1. So that looks like a slope of 2 over 1 and an x. Now, here's my advice, ladies and gentlemen. Always double check your slope more than once. Like, don't just go to one point and just assume, oh, yeah, I'm sure it's fine. Because sometimes that first point can look like it'll be good, but then when you do the slope a couple more times, all of a sudden you're off the line. You have to go back and double check yourself. So let's see, up 2 over 1, up 2 over 1, up 2 over 1, looks good. If your slope works, 2 or 3 times, then you can be pretty confident that the slope works. I didn't want to get rid of all of that, just that part. There we go. All right, now we've got our equation set up, and now we need to turn it into an inequality. We see a solid line, which means it's going to be or equal to, and are we shading above or below? If students ever have trouble with this, here's my advice. I think, okay, imagine this line like it's the roof of a house. I know it would be kind of a steep roof of a house, but just imagine that. Okay, is the shading above the roof or is it below the roof? Well, we can see the shading right there is below it. It's below this roof, so that means y is less than. Y is smaller. That is our answer. Actually, let's rewrite that a little bit better. Undo. There we go. Let's rewrite this as y is less than or equal to just 2x. That's a little simpler. We don't need that plus 0 or the denominator of 1. That's a much better, a much nicer answer. All right, that's example 1. Wasn't too bad. But example 2, what if we have something like this? Same directions, but the graph is drastically different. We can't see either the x or the y-axis. I mean, we could find the slope. I mean, if we're trying to use y equals mx plus b, we could find the slope, no problem. Let's find another good point. This one looks good. So this looks like it's down 2 and right 3. Down 2 and right 3. So that would be negative 2 over 3. Let's just double check that. So let's see, down 2 over 3. Let me write that in. Yep, that would work. And in the other direction, would be up 2, left 3, up 2, left 3. Yeah, that's the correct slope. You always want to check that more than once. Check it a few times. But then, to find the y-intercept, I mean, I guess we technically could like go from this point right here, 159 and 391, and then like try and go up 2 over 3, up 2 over 3, and then like keep on going and create more of a graph. But I mean, who wants to do all that? That'd be a nightmare. What we need is another method besides y equals mx plus b. Y equals mx plus b is not really going to be helpful here. We need something, hopefully you remember, point-slope form. Point-slope form. Now, point-slope form, in case you don't remember, it's right here. It's y minus y1 equals m times x minus x1. Where x1 and y1 are a point, any point on the graph, and m is the slope. Now, for a lot of students, when they see point-slope form, it looks like kind of a mess. It's like, all right, there's a lot more going on here than y equals mx plus b. It looks more complicated. I don't like it. I'm just going to use y equals mx plus b. So a lot of students end up forgetting about point-slope form. But for a problem like this, point-slope form is going to be so much easier than y-intercept form, and I'll show you why. So it's y minus y1 equals m times x minus x1. Now, the big advantage of point-slope form is we can have any point at all. So this point right here, 159, 391, which was pretty much useless when we were trying to use y equals mx plus b, it didn't help at all, or barely at all. If we're using point-slope form, that's just our x1 and our y1. All of a sudden, this point becomes something we can just plug right into our equation. So let's do that. It becomes y minus, let's see, y1 is 391. So 391 equals, our slope, we know that's negative 2 over 3 times x minus our x1 is 159. And there we go. Now, all we have to do is sort of get y by itself, and we know this equal sign right there. Let me circle that. That's going to change. We know this is an inequality, but let's just leave it there as a placeholder for now. So let's see. This becomes y minus 391 equals negative 2/3 x plus 2 over 3 times 159. It's going to be 106. Does that sound about right? Yeah, that could be right. And negative times negative is positive, 106. Then to get y by itself, we just add 391 to both sides. And we get y. And on the other side, we get negative 2 over 3x plus 497. If I'm doing that correctly in my head. 497. Now, we know it's not going to be or equal to because it's dotted line. It's shaded above the line, so y is greater than. Just greater than, not greater than, or equal to. So that's the answer for example 2. So that one really just how do I want to say this? The point of this example was to show you the advantage of using point-slope form. Point-slope form is really useful whenever we cannot easily see the y-intercept. If you've got the y-intercept, by all means, just use y equals mx plus b. All right, let's jump to example 3, which really is our first real example. not real example, but the first example where we're actually doing the objective. We're actually going to create a system of linear inequalities to represent what we have here. So let me scroll down a little bit here just so we can see this a little bit easier. What we have here, we've got this trapezoid, technically an isosceles trapezoid, at least it looks like it, because it looks like the two legs are congruent, at least by appearance. And we're going to create a system of inequalities to represent this shaded figure. So we've got 4 lines here. I'm going to color code this. So we've got blue, green, red, and the last one black. So we've got 4 lines here, which means we're going to have 4 inequalities in our system. Now, I like to start with the easy stuff first, and the ones that are going to be easiest for me are the horizontal lines. Because remember, a horizontal line, all we need is one variable, a horizontal or vertical line. We just need one variable and a number. And since these are both horizontal lines, it's just going to be y is greater than or equal to some number. Because remember, we always, I don't want to say this. Whenever it's vertical or horizontal, we need one variable. And since this line is touching the y-intercept, touching the y-axis, then we know it's going to be a y. So let's get rid of that. So let's do the blue first. So it's y, and let's see. It's shaded below the blue line. So that means it's going to be less than, it's a solid line, so it's less than or equal to, and the number we see there is 4, so it's less than or equal to 4. So we're done with the blue line. That's it. The next easiest one, I think, is going to be the red because that's also horizontal. So I'll try and color code these. So it's going to be y, since it's touching the y-axis. It's above, so it's going to be greater than. It's a solid line, so it's greater than or equal to, and the number is -5. So greater than or equal to -5, and we're done with the red. So far, so good. Now the black or the green. These ones, we're going to need 2 variables. We can't just put y, even if they're touching the y-axis. As soon as they're diagonal, they're slanted in either direction. That means we need a y and an x. So which one's going to be easier? I personally think the black's going to be easier because it's touching the y-axis. Since the black line is touching the y-axis, we can just use y equals mx plus b. So let me see. To find the slope, I'll start down here. Let me find another good point. That looks like a good point. So that looks like it's up 3 and over 1. Let me double check myself. So up 3 over 1, 1, 2, 3 over 1. Yeah. So that slope of 3 over 1 will work fine. So it's going to be, well, that's just 3x for mx. And then we need our y-intercept, which is right there for the black line, which is 4. So this becomes 3x plus 4. And then we just have to fill in our inequalities. So let's see. We imagine this like it's a roof of a building, and the shading is below the roof. So that means y is smaller, so y is less than. It's a solid line, so less than or equal to. Last but not least, you've got the green line. Now, the reason I saved this one for last is because, we know it's going to have a y-intercept, but it's not easy to see. It's not easy to see this y-intercept, so we're going to use point-slope form. I'm going to do my work down here and then bring my final answer back up. So let's write point-slope form. It's y minus y1 equals m times x minus x1. Now, let's see. So we need a point and we need the slope. So it doesn't matter what point we pick. I'm going to pick this one right here, which is, 8, 1. So I'll tell you what, before we even find the slope, let's just plug that in. 8, 1. So it's going to be y minus, tell you what, let me write that down. So 8, 1 was the point we picked. So that's our x1 and y1, just so everyone can sort of follow my thought process here. So minus y1 would be minus 1 equals, we'll fill in our slope in a second. We'll fill in the slope in a second, I should say. I'll just leave it blank for now. And then it's x minus x1 is 8. Now we got to go back and find our slope. Let's find another good point. This one looks good. So that looks like it's down 3 and right 1. Let's do that again. Down 3, right 1. Yeah, so that would be a -3. So that's our slope. Now we're just going to do a little distributing, get y by itself. So we can write this as an inequality. So it's y minus 1 equals -3x. -3 times -8 is positive 24. Add 1 to both sides, and we get y equals -3x plus 25. Now, we're going to have to change that to an inequality in a second, but first let's drag this up to our answer line. So it's -3x plus 25. y, and negative 3x plus 25. And let's see. With this green line, imagine now like it's the roof of the house. The shading is below the roof. So that means y is less than. Since y is smaller, it's shaded below. Y, we think below is smaller. And it's a solid line, so it's or equal to. And this is our system. That's the answer. That's the system that represents this shaded area, this trapezoid in this graph. All right, so hopefully that made sense. Let's do one more before we wrap this video up. So here's example 4. I want you to try this one on your own. All right, so we're going to go over it in 3, 2, 1. Let's go. Write a system of inequalities to represent the shaded figure. Let's color code this just so it's easy to follow along. We'll do blue, green, and red. And red. All right, so my first thought is which one would be easiest to work with? I always look for horizontal lines first, and I see the blue is a horizontal line, so let's do that. It's hitting the y-axis, so that's the variable we're going to use. And its y is, it's less than or equal to, because we're shaded below the solid line. What's the number? 3. Because we see it's right there on 3 on the y-axis. So right away, first one done. Now it's a matter of which slanted line is going to be easier. So for the rest of them, we can't just have y. We need 2 variables, y and x. Because remember, it's only one variable if it's vertical or horizontal. As soon as it's diagonal, you need both. You need y and x. Let's do the green. I think the green is going to be easier because the green is touching the y-intercept. So, excuse me, it's touching the y-axis, so we can easily see the y-intercept. I said that backwards. Since we can see the y-intercept, we can just use y equals mx plus b. So let's do our inequality symbol now. I don't feel like waiting. If we imagine this is the roof of a house, then it would be shaded above. It would be shaded above, which means y is greater than or equal to, since it's another solid line. Let me see. Let's find the slope. That looks like a good point. It's just up 1 over 1, up 1 over 1, up 1 over 1. Yep, just up 1 over 1, which means the slope is 1. So we just put x for mx. And plus b, the y-intercept we see right there is 2. So it's just y is greater than or equal to x plus 2. Just one more to go. And this is going to be the most difficult one because, we know this line has a y-intercept because it keeps on going forever, but it's not easy to see. We could... Let's see. Let's find the slope real quick. Maybe we can get around this just by finding it. So let's see. Pick this point. 1, 2, 1. 1, 2, 1. 1, 2, 1. Yeah, it looks like the slope's a -2. Let's see if we can keep going. Down to 1, 1, 2, 1, 1, 2, 1. Yeah, we could get there. Actually, that wouldn't be too bad to just do a few more squares. But what if we don't actually have graph paper or we're running out of space? Let's just do it with point slope form, just in case anyone wants to see that method. If you're good enough to sort of, not like eyeball it, but sort of keep on going, if you've got enough graph paper to keep on going, you could also do that. But let's use point slope form. Let's see. So what was the slope? M equals -2. Let me rewrite that down here. Let's pick a point. It doesn't matter. I'll pick this one. So that's -7, 1. -7, 1. And we plug it into point slope form, which is y minus y1 equals m times x minus x1. Just showing all my work. If you're good enough to skip some of these steps, that's always a good thing. So let's see. It's going to be y minus equals. I'm so used to putting y equals for slope intercept, but here's y minus. Y1 is 1 equals the slope of -2 times x minus x1 is minus a -7 becomes +7. Okay, becomes +7. Hopefully that's something you're good at. But whenever you subtract a negative, we change that to a positive. Then we just do a little manipulating here. So y minus 1 equals distribute the -2 to get -2x minus 14. Add 1 to both sides, and we get y equals -2x minus 13. Minus 13. I'm going to take that and drag it up and turn that into an inequality. So I'm going to put y and I already -2x minus 13. Yeah, -2x minus 13. And let's see. The red, we imagine this was a roof. If that was a roof, the shading would be above the roof. So it's greater than or equal to, because it's still a solid line. And we are finished. Hopefully that made sense. Let's take a look at the homework. So your homework is page 154, numbers 55 through 57. As always, if you have any trouble with the homework, you have any questions, feel free to reach out to me. But other than that, enjoy the rest of your day.